Look, animals on their own are already cool enough. Why did we feel the need to go and invent more? I'll tell you why. Because humans are inherently selfish, and we can't bring ourselves to appreciate anything we didn't have a hand in creating. That was maybe a bit stronger than I needed to come off. Let me do a better intro. Cryptids are animals that have not yet been attested by traditional sources but are still believed to be real. It, of course, has a corresponding pseudoscience, cryptozoology. Obviously, zoology as a whole would be too hard to encompass in one video, but me being an amateur cladologist, I think I'd take a shot at classifying them. There's one obvious place to start. Bigfoot and relatives are obviously apes.
Except, are they?
Yeah, most likely. There's a reason why ape men are the most common cryptid. Pareidolia forces our brains to search for human faces and human bodies. So why isn't Bigfoot just a Homo sapiens? Well, Uncanny Valley or something, so Bigfoot is a lot hairier than the typical later hominids. The two crucial features of Bigfoot are the hair and that it walks on 2 feet. Now, upright walking wasn't perfected until Homo erectus, hence the name, which was also one of the first to lose its body hair. So Bigfoot would most likely be a close relative of Homo erectus or a descendant of such. This spot is currently occupied by Homo georgicus and Homo naledi, although the former is probably too close and the latter too far. If I had to coin a new name for it, Homo macropus seems appropriate. Of course, if we truly want to be scientific, it should be noted that Bigfoot is actually the biblical figure Cain, but that's no matter. It's hard to declare the second most well-known cryptid, but let's go ahead into the Loch Ness Monster, also known as Nessie, is a cryptid said to reside in Loch Ness in Scotland. Physically, it's harder to get a read on Nessie because Loch Ness has very dark waters, but generally it's been equated with the plesiosaurs, which creates the minor problem that plesiosaurs are freaking enormous. Essentially, Loch Ness doesn't have the ecology to support warm-blooded plesiosaurs. At least not a massive population of them. A small enough population could persist. This 1972 paper by Sheldon and Kerr, and yes, this is real, indicates that a breeding population could exist as long as its biomass falls between these lines. That gives it a length of less than 8 meters, which, cross-referencing it with this 2024 paper by Zhao, gives us a variety of possible genera. Going by shape, a long neck group like Cryptocollidids or Elasmosaurids seems appropriate. Cryptocollidus is great because it covers that entire span. If I had to coin a new specific epithet, Nessensis seems appropriate. Oh, na 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 na. The Mothman, as this diagram indicates, was about 7 feet tall with glowing red eyes. It has a wingspan of 3 meters and can fly up to 100 miles per hour when gliding. But there's one very important point of contention. Does Mothman have arms? He better not. Out of the 4 creatures that have evolved to use wings, only insects have arms as well, and they have an extra set of limbs and can't be scaled up or they would suffocate. But based on its poor perambulation, I'll assume the wings are the arms. That leaves the birds, bats, and pterosaurs. The 2 largest birds are the Cory bustard at up to 4 feet tall, and the Andean condor with a wingspan of over 10 feet long. Neither of them are able to match up to the Mothman. The largest bat is even smaller, with a wingspan of 5 feet and a height of 2.5 feet. That leaves the pterosaurs. The largest pterosaur, Quetzalcoatlus, had a wingspan of over 30 feet and a height of 10 feet. Definitely in the right range of heights, however, you might notice that even though it matches the size, most mainline pterosaurs are way off in terms of shape. Even the broadest, Zzineohp way, is far too spindly, and they all have a stupid pointy crest head, except for one family, the Neurognathids, which couldn't count because they're tiny. So back over to the birds. Pelagornis myocynus is the largest avian dinosaur. However, that's mostly due to its wingspan, and again, its face is too pointy. The proportions don't line up. The next largest bird comes pretty close. Argentavis magnificens has a wingspan close to 5 meters and a body length of around 10 feet, even with a bird's inability to stand up. That could match up. The face shape isn't perfect, and I still don't have an answer to the red eyes, but in the absence of a better answer, I must dub it Argentavis rubrops. So let's jump over to Australia. The Bunyip teeters between a cryptid versus a mythological creature, being a figure of Aboriginal mythology that was co-opted into Australian folklore. It can be pretty difficult to get a read on, so here's what we know. Its body is said to resemble a manatee or hippopotamus. It has a long neck and round head, a tail, a front leg longer than the back leg, and often has sharp tusks. And most importantly, it is aquatic and shaggy with fur. So we're looking for some sort of aquatic mammal. There are 3 such clades: the pinnipeds, cetaceans, and sirenians. The cetaceans don't fit. They don't have legs, and even the basal cetaceans, such as the pachycetids and ambulocetids, have way too pointy of a face, and none of them have tusks anyways. The sirenians, manatees, and dugongs again lack legs. Basal species like Pesosiren portali are strong contenders, but again, it remains tuskless. The walruses seem like where we could pull this one from, but the tree for them is muddy, and unfortunately, comparing genera like Pontolus and Ozotobenus seems to indicate walruses had given up on legs before their tusks grew in. However, what if I told you that there was a fourth clade of aquatic mammals? Desmostylia is an entirely extinct order of aquatic mammals, and yeah, they kind of check all the boxes. A hippo-like body, front and back legs, long neck, and yeah, tusks. Reconstructions vary, but so do depictions of the bunyip, so I'm happy placing it as Desmostylus hesperus. Although since all the other ones got a species, I'll instead make it D. bunyip. So next has got to be the Chupacabra. Like most cryptids, there isn't a good singular definition of a Chupacabra, but for this one specifically, there are two conflicting accounts. The more well-known Mexican Chupacabra resembles a hairless canine. This is by far the easiest one, because specimens have been brought back and identified as dogs or coyotes suffering from mange, an easy Canis lupus. But the original Puerto Rican Chupacabra is a lizard-like biped with fangs and bristles on its back, and it moves by hopping. So to determine what kind of animal it could be, we need to study somewhat the biology of the only other hoppy animal, the kangaroo. So the kangaroo is upright bipedal and has a long muscly tail it uses for balance. In terms of reptiles, you might immediately jump to theropods like Dromaeosaurus and Coelurus, but these are too slender and bird-looking, so I prefer stockier options. Basal members of the Pachycephalosauridae fall into a stem group entitled Heterodontosauridae, lizards with different teeth. These different teeth are actually sharpened canines, which could easily explain the fangs of the Chupacabra. Additionally, modern reconstructions depict Heterodontosaurus with bristles instead of scales. There's just one problem, which is that Heterodontosaurus is tiny and thought to be herbivorous. But as it stands upright and learns to hop, it can certainly grow a little and develop a taste for blood. I give you H. sanguisuga. By popular request, the populace in question being my friend, we now move on to the squonk. The squonk is really ugly, so it runs away and cries about how ugly it is. And if anyone sees it, then it cries so hard it dissolves itself. Hmm. It's generally depicted very porcine, but its loose-fitting skin makes me more partial to a sort of bulldog-like animal. Though I suppose the bagginess of a bulldog is mostly due to selective breeding, I imagine a similar effect could be produced on a hog. So my best guess would be Sus lacrimosus, or more likely SD lacrimosus. The Mongolian deathworm is a species of worm native to Mongolia. It has a red body about 6 feet long, it burrows underground, and both its head and tail have a mouth full of fangs. You might be tempted to jump straight on the worm train, but I have biological reasons to ignore this. You see, worms have a very high water content. There's no way they could live in a desert. That also knocks out the Caecilian, a group of amphibians. Looking at other vermiform creatures, it gives us slim pickings. The largest species of desert snake is the Central African rock python, and the largest snake in the region is the Tatar sand boa. However, the sand boa can't reach longer than 4 feet, and neither are venomous. Venomous desert cobras reach similar lengths, and none of them are red anyways. So we bounce back to the invertebrates. Modern day myriapods like the centipede and millipede can be found in deserts, but they're too small. Giant extinct species exist, but guess what? They couldn't breathe in today's atmosphere, so we're stuck. So there is a fortunate note about the mouth. Glycera dibranchiata, a species of bloodworm, forms its teeth out of the copper it ingests, mixed with other proteins. Yes, it's called a bloodworm, it has metal teeth. We don't need to get into it. Point being, it doesn't necessarily need to be in a clade that has teeth. And another saving grace, the Mongolian deathworm could be poisonous, not venomous, and some poisonous animals don't have to make their own poison, but rather ingest poisonous creatures and steal their toxin, which does seem to match up with the absurd overkill. So, screw oxygen, is there a centipede that does it? Well, being invertebrates, the fossil record has not been kind to centipedes, especially since their heyday was during the Carboniferous, almost 4 times as far back as the dinosaurs it competes with. The only extinct megacenipede is Arthropleura, which matches in size but was A. herbivorous and B. probably lived in a jungle, but nevertheless, it's too few options, I'm not finna pass on this body. By far, my weakest classification is Arthropleura thanatovermis. So that was fun. If you guys want me to do another, that's too bad. There's no way I have it in me.